Indexes. Indexes are a database object that we can create attached to a table for specific columns that will speed up our queries. Our queries can utilize the indexes to take shortcuts to the data. So in this nugget, we're going to break that statement down to understand exactly what indexes do, how they work, and we're going to get familiar with the two most popular index types here in SQL Server: clustered and non-clustered indexes. Let's jump in. Simply put, indexes speed up the performance of queries very much like the index in the back of a book. If you're looking for something specific in a book, are you going to flip page by page to find it? Or are you going to jump to the index, which is sorted alphabetically, quickly find it, find what page it's on, and then flip right to that page? That's in essence what an index does for our queries. And that's exactly what a query does to a table without an index. It steps through it row by row until it's read every single record in that table to figure out if it qualifies for the results, as opposed to a query that uses an index. And again, just think of an index just like that index in the back of the book. It's a separate data structure. It's organized or sorted, and it contains references to where the data actually lives inside of the pages. Same thing. Query hits an index. The index is going to say, oh, I know where that piece lives, I know where that piece lives, and I know where that piece lives. And it just needs to go and do those reads for that specific data. It doesn't have to do a full scan to find what data qualifies for the results. Now let's peer inside of an index to understand how they're structured and how they work. And I'm going to use one of my favorite analogies out there, the card analogy. So let's say that I gave you a deck of 52 cards, and I said, you know what, go find me the 10 of hearts. What are you going to do to find the 10 of hearts? You're going to flip. You're going to scan. You're going to flip through every single card in that deck, which means you're going to scan all 52 cards, right? And on average, you're going to find that 10 of hearts after 26 flips. If you did it enough times, that's what your average would be. Let's look at a better method of doing that. Let's say we broke that pile down into 4 piles by suit, which would give us 13 cards per pile, right? We've got clubs, spades, hearts, and diamonds. Now, on average, it's going to take us 2 times to find which pile contains the hearts. And then it's going to take us 7 times, roughly, to find the 10 of hearts in that pile, which gives us a total of 9 flips. Far more efficient than scanning the entire deck, which would on average take us 26 flips. And you can even go you could take this by breaking it down even further, right? And so we could put ace through 6 on this side, 7 through king on this side for each one of these, and that would even further reduce us to 6 flips. This is what an index is all about. An index builds what's known as a balanced tree. So when we build an index in SQL Server or any other database platform out there, we are going to specify the key for that index. The key is the column or columns that are going to contain the data that make up this index. Just like our example here, we've got 2 columns in here, right? We've got the card value as well as the card suit. And the combination of those is the key for the index, which makes up the data for the index. So when a query comes in for this kind of data, it can navigate that balanced tree and make a decision, left or right, left or right, left or right, until it either gets to the data or gets to a pointer to where the data lives. And that's why indexes are so efficient, because they only need to scan what they need to scan, no more, no less. In SQL Server, we have 2 different kinds of indexes, clustered and non-clustered. A clustered index physically stores the data for the table in the index. So if you have a table out there and you have no indexes on it, no clustered index anyway, then what's going to happen is underneath that table, inside of what are known as the data pages, it's just literally just going to be the data. So just think of it as a big steaming pile of data and no order whatsoever. And that's why queries that hit a table that has no clustered index, this is known as a heap, by the way, need to do full table scans to find the data. A table with a clustered index, however, will have a balanced tree underneath it, right? So it'll look just like we have below there, like so, and that is the data. The data actually lives in the bottom layer right here, what's known as the leaf layer, or the leaf nodes. This up here is called the root node, and then we have intermediate nodes, one or many intermediate nodes. So this is why you can only have 1 clustered index per table, because it literally is the data for the table. And all queries that hit the table will navigate the clustered index to find the data, because it lives right down here. So that's why every table should have a clustered index. There are very few cases where you wouldn't want a clustered index on a table. And in fact, every time we've created a primary key in this course, on all those auto number fields, it automatically has created a clustered index under the hood for us because that is the default behavior. Now our second index type is the one that you're going to be creating the most of when you're trying to optimize queries or trying to do what's called covering a query, and that is creating an index for a specific query. These are separate structures ordered by index key, just like we were talking about in the beginning of this nugget in that first slide. It's just like the index in the back of the book, and this is also why we can have many per table, because it's not a clustered index, it's not the physical data, it's a separate structure that points to the physical data. So it's structured the same way, right? It's a balanced tree. We have a root node, we have potentially many intermediate nodes, and then we have a leaf layer down here. And this leaf layer, rather than containing the actual data like a clustered index, contains pointers to the data. If you have a clustered index on your table, then it's going to contain pointers to the leaf nodes inside of the clustered index. If not, it's going to contain pointers to the row IDs inside of a heap. And now we're getting a little crazy here for database fundamentals and just introducing you to indexes, but the most important things to take away here is that a clustered index physically stores the data in the index. So anything that needs to get at the data needs to go through that clustered index. And clustered indexes are very, very fast, so that's why it's generally a good idea to always have one on your table. And you can only have one on your table. Where non-clustered indexes is what we're going to be using to speed up specific queries. We can have many on a table, and it's a separate structure. Let's jump into the Virtual Nugget Lab. I'll show you how we can create clustered and non-clustered indexes. Welcome back to the Virtual Nugget Lab. Let's jump into SQL Server Management Studio. We have a project here, 14 indexes, and if you want to try this demo out on your own, just make sure to run setup.sql first. That's going to set up your test database here, testDB, with the state that we need to run everything that we're going to do. And this is going to set up the learner certification exam vendor and learner certifications table that we've been working with here for the past couple of nuggets. So we're going to do a couple of things in here, and the first thing I want to do is show you clustered indexes. Let's take a peek at a couple of these tables. If we expand our certification table, look at columns, look at that. There's our certification ID, which is our primary key, which we can see here. And if we expand indexes, whoa, we've got a clustered index on this table already. And look at that, it's the same exact name as our primary key. So if we look at the properties for this clustered index, we can see that indeed it's a clustered index with this name on top of certification ID. That's the key column for this clustered index. So all the data for this table lives at the leaf level of this clustered index. And you can actually see that. If we head over to fragmentation, and by the way, index maintenance is a huge topic and a big part of every single DBA's daily responsibilities. And that's because these indexes are stored in pages, the actual index data. So SQL Server, whenever data modifications come in, SQL Server has to put data on those pages, right, to build out the index. And when those pages get full, they split and fragmentation occurs. So a big responsibility for DBAs is to ensure that they do index maintenance, to either rebuild or reorganize those indexes. We'll save that for another time. But if you look at the fragmentation node and head down here, look right here, leaf level rows. We've got 10 rows in this table, and they all live at the leaf level of this clustered index. All right, let's close out of this one. And let's take a look at another table here. Let's look at our vendor table. Now, notice our vendor table doesn't have anything going on. No indexes, no primary key. And so if we were to run a query here, what's going to happen? Let's just switch databases here. What's going to happen? It's going to do a full table scan. And now, you can't really tell from here, but see this little button right up here, include actual execution plan? I won't go too deep into this. This is more of an advanced topic, but this is great because it shows you how much your query cost and what it did. So we're going to click on that to turn it on, and we're going to re-execute our query. And you're going to get another little tab right here. And look at that. It did a table scan. You can get a bunch of information and statistics and metrics around that table scan, but it did a table scan, and these are bad. You don't want to see these in execution plans because they're going to be very expensive for your database server. So let's go ahead and design our vendor table, and let's just put a primary key right on that vendor ID. Let's save it, and now we should have a clustered index right on that column. There it is. Now let's try that again. We've already got it turned on, so we should see the execution plan. And look at that. Now it did a clustered index scan, which is great. Far more efficient than a table scan. So now whenever you see a create table statement, here's the create table statement for our certification table, and you see primary key clustered, now you know clustered actually means it's going to create the clustered index as the primary key. And even if you take this off, it will default to a clustered index because that is the default. You'd have to specifically say non-clustered if you want your primary key to be a non-clustered index, just in case you have a better candidate out there as your clustered index, which again is going to form the basis for all the data in the table. So here's a couple of queries just to show you that you can execute 2 queries at once with your execution plan turned on and see what they both look like. So these are both going to do clustered index scans because our certification table does have a clustered index, not a full table scan because we've got a clustered index. Now let's move on to non-clustered indexes. There's a couple of ways we can create a non-clustered index. We can do so using the create non-clustered index statement followed by a name and then on what table and what column or columns you want to create it. Now here we're going to create a multi-column non-clustered index. We're going to say we've got queries coming in that are constantly hitting these columns. And by the way, that's a great way to design your indexes. What a lot of DBAs will do, and we've got tools all over the place in SQL Server that will allow us to capture the 10 most popular queries that hit our database or that hit our server. And then we can go index around those columns. And what you generally want to do is look at the where clauses and find the columns that are most commonly used in where clauses and put indexes on them. Because columns that are in the where clause that hit an index are going to use the index and be far more efficient than ones that do not. The other way that you can create a non-clustered index, by the way, let's go to our exam table, is just right-clicking on indexes, choose new index, and notice we can't choose clustered index because we already have one on this table, and choose non-clustered index. There it is. So now we can use the GUI to do this. We can come down here inside of our index key columns and hit add if we want to specify what columns we want to add in here, and you've got some options in there as well. But we're just going to do this using SQL here. I've already got it highlighted. Let's go ahead and click execute. That's going to create it. And now if we expand indexes, there is our new index. And notice that we've got our unique constraint, which is just a unique index down in here as well. We have our clustered index here, and here is what a non-clustered index looks like. So now if we were to run this query right here, select everything from our exam table, what's it going to use? It's actually far more efficient to just scan the clustered index to get that information. But what if we have a specific query that pulls out the name and the cost? What that's going to do is just use the non-clustered index. Check this out. It did an index scan on the non-clustered index, not on the clustered index. We didn't see the clustered index at all, by the way, in this execution plan because it can get, if your queries can get everything out of the index, it will get everything out of the index. And that's a highly efficient query, and that's why it helps to understand the kind of queries that are hitting your database and to profile them and monitor them and then create indexes around the data that those queries are pulling out. Because if you can get a query to just pull from the index, you're doing more than all right in your databases. Let's take that one more step. Let's say that we wanted to create an index on the data acquired field inside of our learner certifications table because we've got a query that has data acquired in it as well as has a where clause with data acquired. Now let's look at this query before we put an index on it. Check it out. Look what it's doing. It's using all clustered indexes from all 3 of those tables. It's scanning, getting all the data out of them, and then doing some internal joining to pull back the data that we need. So right now, this query is pulling, just scanning all of those clustered indexes because each one of these tables has a clustered index on it. Let's create this non-clustered index on data acquired. All right, there it is. If we expand our table here, learner certifications, let's look at indexes. Let's just refresh. Oh, it's right there. I don't even need to refresh. There it is, right there. Okay, now let's run this query again. Execution plan. What happened? Look at this. It did an index scan there, which was 30% of the cost, and then it did clustered index seeks here on our other 2 tables. So while this is good because it's using our index, it still has to use the other indexes, clustered indexes, to get this information. So this part of the query was good. And that's why this query was like the ultimate, right? Because we created a non-clustered index that contained everything, that satisfied everything that this query needed. That's why it just hit the index real quick and it was done. So there's a good look at clustered versus non-clustered indexes. Remember, a big part of database design is developing a sound indexing strategy. And a lot of times that just means understanding the kinds of queries that are hitting your databases. And if you're experiencing slow queries, then you may want to look at it to see if it's hitting an index, and if not, creating one for it. In this CBT Nugget, we covered indexes. We saw that indexes are a database object we can use to speed up our queries. We saw what they look like. They're balanced trees, which is a structure that our queries can use to more efficiently navigate to find the data without having to scan the entire table of data. We also got familiar with the 2 major kinds of indexes here in SQL Server, clustered and non-clustered indexes, and saw how to create them in the Virtual Nugget Lab. I hope this has been informative for you, and I'd like to thank you for viewing.